In this video, we want to look at a couple special right triangles. Particularly, we want to figure out how can we determine uh, the acute angles of that right triangle and the measures of the sides of the right triangle. So we're going to do this twice. We're going to start using a square, and then we'll do it again using an equilateral triangle. So again, this first time here, we're going to start with the square. So remember, squares, it's four-sided shape. The length of all the sides are equal to each other. All the angles are 90 degrees. And so in particular, what we want to work with is we want a square whose diagonal has a length of 1. And so if we take this square and we sort of cut it down the diagonal, it produces a right triangle. Okay? And we know that the length of that diagonal, which is now the hypotenuse of that right triangle, it has a length of 1. And so what we want to do is figure out the length of the other two sides of the right triangle. But again, since it's a square, these two sides are going to be equal to each other. So we could just label them both x and x. Okay. So to find the measure, or to find the length of x, we could use the Pythagorean theorem. So we know, that a squared plus b squared is equal to c squared. And in this case, the a and the b are both x. So we have x squared plus x squared is equal to 1 squared. And that gives us 2x squared is equal to 1, and which means x squared is equal to a half. And so to figure out what x is, we could take the square root of both sides of that equation. So that would give us x is equal to, remember when you take the square root of both sides, you have to take plus or minus. So it's the square root of 1/2. And we just want to simplify this a little bit here. So I know that if you take the square root of a fraction, you can take the square root of the top and the bottoms of the numerator and the denominator separately. The square root of a 1 is just 1. And I can't do anything with that 2. So we're going to have 1 over the square root of 2. And we like to rationalize fractions that have a square root in the denominator. So we're going to multiply the top and bottom by a square root of 2. And so when we do that, we'll have x is equal to plus or minus a square root of 2 in the numerator. And in the denominator, when you take a square root of 2 times a square root of 2, you would get a square root of 4, but the square root of 4 is just a 2. So we get x is equal to plus or minus the square root of 2 over 2. Since we're talking about the length of triangles, we don't need to worry about the negative. So the length of these two sides of the triangle are both square root of 2 over square root of 2. Okay, so we now have a right triangle, and we know the length of the hypotenuse and the length of the two legs. So if the hypotenuse is 1, then both the legs have a length of square root of 2 over 2. And we also want to figure out the angles. So again, we know since it's a right triangle, there's the right angle, and then the other two angles, because this is a square, when we draw that hypotenuse diagonally through the square, it is bisecting, or it's cutting in half, the two 90-degree angles that it extends through. And so in this case, if you take half of each of these 90-degree angles, we're going to get a 45-degree angle. So, and they're going to be equal to each other, right? Because it's a square. So we have a right triangle with two 45-degree angles, and the hypotenuse has a length of 1, and the two legs are square root of 2 over 2. And we will commonly refer to this as a 45, 45, 90 triangle. Again, that's just giving us the measure of the angles, right? So if we have a 45, 45, 90 triangle, then we know, in particular here, when we're going to talk about our trig functions, we know we have a right triangle with a hypotenuse of 1, and then both the sides are square root of 2 over 2. Okay, so keep this in mind as we keep working forward with our trig functions and stuff. The second example that we want to work with here is an equilateral triangle. So equilateral triangles, just kind of like squares, all three sides are the same length, and then all the angles are the same. Well, we can hit the angles here real quick. We know that the sum of all three angles has to be 180 degrees, and since there's three of them, if we take 180 degrees and divide it by 3, we get 60. So I know that each of these angles is 60 degrees. Okay. So we want to deal with a right triangle in this case. And so just kind of like we divided the square in half, we're going to divide this triangle in half. And I can do it any way I want, but I'm just going to draw this vertical line through the top angle down to the bottom base side. And so we're going to create a height here, and that is a perpendicular side, and that creates another right triangle. Let's maybe just quickly tackle the angles. I know the bottom angle here is 60 degrees, right? Because it's the angle of the equilateral triangle. We have that right angle as well as the bottom. And what about the little angle up here at the top? Okay. Well, again, that vertical side I drew, because it's an equilateral triangle, that vertical perpendicular side here, it bisects that top angle in half. And so it turns out that this one then is 30 degrees. So we have a right triangle with a 30 degree and a 60 degree angle. And you may have already guessed it, but we're going to call this a 30, 60, 90 triangle. Okay, so let's go ahead and figure out, we have the angles, let's go ahead and figure out the lengths of the side. And we're going to specifically deal with, again, what if the hypotenuse has a length of 1, just like we did with the square. So how do we figure out the lengths of these sides? Well, we can actually get the bottom side kind of directly. We know the whole bottom side, whole bottom length here is a 1, right? Because it's an equilateral triangle, and we're assuming the hypotenuse of this right triangle is also a 1. And again, this height, this vertical line that I drew in here, because it bisects the angle at the top, it also has to bisect the line segment at the bottom. So that means this, where this right angle is, it is right in the middle between the other two 60-degree angles on the outside. And so that means this short half is actually half. It is half of the whole length, which means it is half of a 1. So it's a half. So we actually have 2 of the sides already. We have the length of the hypotenuse, and we know the shorter side of this right triangle, so it's the side opposite the 30, is a half. So all that's left is to figure out this missing side over here, the length of that vertical side, and we can call it x if you want, and we'll do Pythagorean theorem again. So again, a squared plus b squared is equal to c squared. We could say the a is, say it's the x. The b would be the half, so x squared plus 1/2 squared has to equal c, which is the hypotenuse, and that's a 1, so 1 squared. So we simplify this a little bit. We'll have x squared plus 1/2 squared becomes 1/4, and that will equal 1. We then need to subtract a 1/2 from, or sorry, 1/4 from each side. And when we do that, it might be helpful to think of this 1 as a common denominator. So 1 would really be 4/4. So when we subtract this 1/4 to the other side, we're still left with an x squared on the left side. And on the right side, we're going to have a 4/4 minus a 1/4. And that leaves us with a 3/4, right? We just subtract the numerator. So 4 minus 1 is 3. Then to isolate x, we're going to take the square root of both sides. So x will equal, and again, when we do square roots of both sides of equations, we get plus or minus. So plus or minus the square root of 3/4. And just like we did before, we can split the square root up over the fraction. So the square root of 3 is, well, 3 is prime, so I can't break its square root down any further. So it's the square root of 3. And then the denominator, the square root of 4, is just a 2. So we find out that x, which is the length of this longer side of the triangle, is equal to plus or minus root 3, square root of 3 over 2. And again, we don't want to deal with a negative, so we'll just say the length of this side is a square root of 3 over 2. Okay, so a 30, 60, 90 triangle has a 30, 60, and 90 degree angle. The length of the hypotenuse is 1. The length of the side opposite the 30 degree side, or the 30 degree angle, is a half. And the length of the side opposite the 60 degree angle is a root 3 over 2.